Welcome to Case Study 02, Network Joins. I'll be your TA for this explainer. Let's get right into it. In systems engineering, data is rarely handed to you as a perfectly packaged network graph. Usually, it's scattered everywhere. Think about a concrete scenario. You're analyzing Boston's transit network, and a city planner hits you with a specific question. How many morning rush rides started and ended in a majority black block group? Immediately, you hit a structural wall. Your trip data, the edges of the network, is sitting in one table, containing ride volumes. But the demographic data, the attributes of your nodes, lives in a completely different table. To actually see the flow of the network, you have to find a way to fuse them together.
And that brings us to identify, the very first of the 4 professional skills we're building in this course. Identifying is all about taking messy, real-world relational data and framing it as a graph that actually answers a specific question. The naive alternative, what a lot of engineers instinctively reach for when faced with 2 tables, is to just run endless spreadsheet lookups until something eventually breaks. That might work for a dozen rows, but it completely falls apart when you need to ask structural questions about tens of thousands of transit trips. We need a systematic, network-aware approach.
So, before you even think about touching the interactive tool or writing a single line of code, grab your physical sketchpad. Seriously, I want you to draw these 2 raw tables side by side just like this. On the left, sketch out your edge table with FromID, ToID, and volume units. On the right, sketch your node table with node ID, the neighborhood cluster, and that crucial demographic flag, MageBlack. Make a mental note right now. The actual engineering thinking happens right here on paper, long before you open your code editor.
Next, take your marker and literally draw an arrow from ID in your edge table directly over to node ID in your node table. That physical line you just drew, that is your join key. By making that mark, you are explicitly defining how the origin station of a transit trip maps to the attributes of that specific station. Conceptually, you're performing a single node join. You're grabbing the traits of the start node and sticking them right onto the edge.
Let's pause and anticipate what happens next. If you follow that arrow and actually execute the join, what is your resulting table going to look like? Well, you'll have a single, wider table. It still holds your original edge data, FromID, ToID, and volume units, but now it's hauling around the MageBlack flag for the origin station too. You've successfully tagged an edge with a trait from its start node.
But think back to our planner's original question. We need to know if the trip started and ended in specific block groups. A single node join just won't cut it here. We need both ends of the trip. In the interactive lab, you'll use a drag-and-drop pipeline builder to construct a double node join. The sequence looks exactly like this. First, you left join the origin nodes just like we sketched. Second, you left join the destination nodes using the ToID. Third, and this is absolutely crucial, you rename the columns to resolve collisions. Finally, you group by and summarize to get your final count.
This brings us to an essential learning check, and I want you to really think about the mechanics of this. What actually happens to the MageBlack column if you join the node table to the edge table twice, once for the start station and once for the end station? Both times, the database is trying to pull in a column with the exact same name. I'm deliberately not going to give away the final aggregated number here. You'll figure that out yourself when you run the pipeline. But I want you to anticipate the structural headache this creates in your dataset. Once you've nailed down the concept in the browser lab, you'll move on to the coding exercise. You can pick either the R track using dplyr or the Python track using pandas. You'll run example.r or example.py right on your local machine. And here is the incredibly satisfying part. Doing this the right way, defining your joins and aggregations cleanly in code, means this entire pipeline is going to process a dataset of 50,000 morning rush hour trips in well under 10 seconds. But before you write a single line of that code, we need to dismantle one massive misconception. If you join the node table twice without renaming your columns, you get a broken join. The columns collide. R or Python will automatically force a lazy rename to something completely unhelpful, like MageBlack.x and MageBlack.y. That leads to devastating, silent errors downstream. You might think you're analyzing destination demographics, but you're actually aggregating the origin. The working join shows the fix, explicitly renaming these columns to start black and end black immediately after the merge. Hear me on this. The rename step is not optional polish. It is literally the only thing preventing a silent collision error when you're analyzing edge traits. Which brings us to your final task before you open the case study. I want you to pause this explainer, take out your physical sketchpad, and draw this prompt by hand. Pick 3 real tables, maybe from a past project, your current work, or just a realistic engineering scenario.
Part A, draw the boxes and draw arrows marking the specific join keys. Part B, write out explicitly which two columns will collide when you do a double join. And Part C, write down their new _origin and _desc names. Take the time to do this. Do the heavy thinking on your sketchpad right now. If you do, I promise you, the coding tool will feel like simple execution.